Hello and welcome back to this channel, and today we are going to discuss about 27th Jan second shift paper. Okay, 27th Jan second shift paper. So if you ask me that what is the overall quality of this paper, so I will say it's easy, but the first shift paper was more easier. That was easier. Second shift paper is also easy. You can definitely score at least 22 to 23 questions from here, and like this paper is quite easy and you will get marks from this chemistry part, right? So okay, so without wasting any time, we should start and we will solve this question. Again, I am telling you, no tricks, no anything. If any logical tricks are there, that I will apply, but it's simply normal chemistry. It's just basic chemistry. It's very easier to understand, very easy to understand. You just have to be with me. Okay, so it is given for a first order reaction, time required for T 99.9% completion. Okay, so the first thing that I want to tell you is that T what do I say, T 75% is to T 50%. This relation, T 87.5% is to T 50%, T 90% is to T 50%, T 99% is to T 50%, then T 99.9% is to T 50%. All of these I have discussed in my classes. Okay, so here the question is about this last part. Okay sir, so how to do it? So you see, T equal to, we can write 1 by K ln A naught by A, 1 by K ln A naught by K. Why? Because it's a first order reaction. And sir, we can write that T half is equal to ln 2 by K. T half equal to ln 2 by K. That I can write. Okay, now you see I am putting the value. So 1 by K, if I am doing it for T 99.9%, then I should put ln. If 99.9% means what? Your initial was A naught. Initial A naught is 100%. Then A that is left is 100 minus 99.9. Now tell me, do you understand this or not? So 1 by K ln 100 by 0.1. We can write 1 by K ln 1000. Now you see, in your T half thing you are having ln 2. In your T half you are having ln 2. I want to write this in the form of ln 2. Sir, how to do it? You see, 2 to the power 1 means 2, 2 means 4, 3 means 8, 4 means 16, 5 means 32, 6 means 64, 7 means 128, 8 means 256, 9 means 512, and 10 means it is 1024. So this 1000, can I write it near about 1 by K ln 2 to the power 10? Definitely sir, you can write, but it's near about. Okay, then this 10 can I take outside? Yes sir, 10 into 1 by K ln 2 you can write, and this value is nothing but T half. 10 into T half. Are you getting my point? That ln 2 by K, it is nothing but T half. So in place of this I am writing T half. So 10 into T half, that means option number 4 is your correct answer. Option number 4 is your correct answer. So by this way you have to do these questions. So easy, right? So easy. And if you want, you can do T 75%, T 50%. This value will come as 2:1. You can do these things. Okay. Now going to the next question, a number of non-polar molecules among the following. You see, if I start from very basic, then I should write their structure. How to write? So HF is like this, and F is more electronegative. So it is minus delta, and this is plus delta. So sir, there are charge separation. So sir, this is polar. Okay, H2O is sp3 hybridization and with two lone pair like this, then sir, this dipole moment is like this, dill dipole moment is like this, and the lone pairs, their dipole moment are like this. So overall the dipole moment is like this. So definitely sir, this is also polar. CO2, if you do the CO2 hybridization, in the previous video only I solved a question based on hybridization. Okay, please check this video how I am calculating. I am not doing this right now here. Okay, or you want me to do it? Or do you want me to do it? Oh my god. Okay, let's do it. So H calculation, how to calculate H equal to half of number of valence shell electron of the central atom, okay, plus number of univalent atom minus charge of cation plus charge of anion. This is the formula. Now for carbon, what is the valence shell electron, number of valence shell electron, that is 4, plus univalent atom. Oxygen is univalent? No, oxygen is not univalent. Oxygen is bivalent. Sulfur is bivalent. You cannot take that. What you can take, say, H plus, Cl minus, Br minus, I minus, they all are univalent. I am not asking if that is like positively charged or negatively charged, not like that. If they are univalent, it's okay. Uni positive, uni negative, that is not a problem. Okay, so oxygen I cannot take. So sir, you cannot take anything. This is like this. So you see half into 4, that means 2, and 2 means it is sp hybridization. This is our linear structure. Sir, linear structure means this will be looking like this, right? C double bond O, this dipole moment and this dipole moment will be cancelled out, and it is ultimately non-polar. So they are asking for non-polar. I already got CO2 as non-polar. Okay, so by this way you have to do this for every molecule. If I want to do, then it will be a time taking one, but whatever I have to do, I feel that I will do. Okay, NH3, I hope you know NH3 structure is like this. Okay, so this dipole moment, and the lone pair dipole moment, all are on the upside, all are directed towards the upside. So sir, this is definitely polar. But sir, I don't know the structure of SO2, so I cannot say if it is polar or non-polar. Okay, if you don't know, no problem. Calculate H equal to half of sulfur is from group 16, so valence electron is 6, plus oxygen I cannot take anything, said 0. So half into 6, that means 3 means sp2. Sir, bond pair 2 oxygen, so bond pair is 2, and lone pair hybridization value is 3, bond pair is 2, so lone pair is 3 minus 2, that means 1. So it looks like this, S double bond O and a lone pair like that. It looks like this. Sir, if it is looking like this, then this dipole moment and this dipole moment, the resultant is like this, and lone pair is having a dipole moment. So they are opposite, but they are not exactly cancelling out each other. Why? Because you see their magnitude and this lone pair magnitude, the magnitude is different. They are not the same. So mu not equal to 0, and this molecule is also polar. Are you getting my point? Okay. Now H2, obviously H, it will be non-polar. There is nothing to discuss, right? This is non-polar. There is nothing to discuss. CH4, it looks like this, carbon with a hydrogen like this, ideal tetrahedral, and if it is ideal tetrahedral, sir, this is also non-polar, because all the dipole moment will be cancelled out by each other, the resultant. And now sir, I don't know about BF3. Okay, so BF3 we have to do. BF3 we have to do. If we do BF3, sir, calculate H equal to half of. Boron is from group 13. So valence electron is 3 and fluorine is F minus, I can take, so equal to 3. So half into 6, that means 3, means sp2, means trigonal planar. Trigonal planar. If this is the case and you see bond pair is 3, because 3 fluorine is there, that means lone pair is 0, because H value is 3, bond pair is 3, so no lone pair. So sir, how can you put the values? So I can put like, how can you put the arrangement? So I can put it like this, like this, and all these bonds are 120 degree. All these bonds are 120 degree. Now I hope you know about vector, right? I hope you know about vector. This bond dipole moment, this bond dipole moment, and this bond dipole moment, if they are 120 degree apart, you calculate mu resultant is equal to root over mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. Like this, if you calculate, you will get all of them are cancelling out each other. I hope you know. If you don't, you please revert back to me. I will be very happy to help you, okay, in this calculation. I love these calculations, okay. So yes, and if you calculate, ultimately it will be cancelling out each other, and mu value you will get ultimately 0, so it will be non-polar. So what are the molecules you got non-polar, sir? I got non-polar CO2, I got non-polar H2, I got non-polar BF3, and I got non-polar CH4. So total 4 elements, 4 molecules are there who are I guess yes, they are 4 molecules, they are non-polar. Are you getting my point? So 4 will be your answer here, okay. Now coming back to this, okay, 3 molar NaOH solution is to be prepared using 84 gram NaOH. Then the volume of the solution in liter. Okay, it's a very good question. So whenever the question is given in this way, so what you have to do is you always start with this 3 molar. You always starts with the formula or the equation from 3 molar NaOH. Now they are asking for molarity set. Now to do this type of question, what you need a very firm knowledge about these things. Molarity set. What is molarity? Molarity, I can say number of moles of solute, per 1000 ml, or we can say, I think it is going behind me, number of moles of solute per 1000 ml, or 1000 ml means we can write 1 liter also, 1 liter solution, number of moles of solute per 1000 ml solution. Okay, sir, so I have to satisfy it. So can I write that number of, okay, don't do like this way, okay. So you see what is given, 84 gram is given in a solution of 1 liter. You take the solution liter as x liter. Okay, you take as x liter. So can I write now? Can I write that in x liter solution, NaOH dissolved, in x liter solution, NaOH dissolved 84 gram. Yes, sir, you can write. In x liter solution, NaOH dissolved is 84 gram. But sir, the problem here is I don't want this as 84 gram. I want this as number of moles. So sir, how to calculate number of moles? Number of moles, how to calculate? Number of moles is what? Given mass by molecular mass. Given mass by molecular mass. So sir, can I write it like this way? X liter solution, in x liter solution, NaOH dissolved is 84 by its molecular weight of NaOH is 40 gram. Can I write it? 84 by 40, not gram, NaOH by 40 mole. I can write, yes sir. So number of mole you got number of mole, that 84 by 40 mole NaOH. But sir, it is in x liter. you want it in 1 liter. To satisfy the molarity definition, number of mole should be in 1 liter. Now I got in x liter. So in x liter solution, NaOH dissolved is 84/40. I want to do it in 1 liter solution. Said yes, definitely you can do. It will be 84/40 into x mole. And you see, now you got what you got. You got in 1 liter solution, NaOH dissolved is this mole, and this is nothing but your molarity, and molarity value is given 3. So just you have to equate the equation. So sir, you are talking about that, yes, 84/40 into x is equal to 3. So x equal to, you can write 84/40 into 3, like that. Okay, this you can write. So it will be 28/40, it will be 0.7. So x value is 0.7. Then the volume of the solution in liter is something in 10 to the power minus 1. So you have to write it as 7 into 10 to the power minus 1. So x value, your answer will be 7 will be your answer. Got it or not? Nothing, you just have to satisfy the molarity equation. You just have to satisfy the molarity definition. Molarity is number of moles of solute per 1000 ml or 1 liter solution. So what I have done, I have taken x liter solution. In x liter, NaOH dissolved is 84 gram. But sir, I don't want it in gram, I want it in mole. So no problem, given mass by molecular mass, you do 84/40 number of mole. But sir, this number of mole I got in x liter, I want this in 1 liter. So in 1 liter, this is the thing satisfied. Molarity is 3 molar. Equate the thing and you will get your answer as 7. Okay, as 7. Okay. Going to the next question. What is given? This question is quite good. Like in photography, you see it's AgBr always. It is always silver bromide. In photography plate, it's always silver bromide. Okay. Then Haber process, yes, Haber process is for ammonia synthesis. Haber process is for ammonia synthesis, right? Ammonia synthesis, that means N2 plus 3H2, from here you will get 2NH3, and yes, you need Fe as a catalyst. You need Fe as a catalyst here. Okay. Then there is one thing that is called Ziegler-Natta catalyst. This is very important. So suppose you are having ethene, right? Or we can say ethylene, N number, and from there you want to make polythene. You want to make polythene. Okay, polythene. If you want to make, for that you have to use Ziegler-Natta catalyst. I have told you in the class that we have to use Ziegler-Natta catalyst. So Ziegler-Natta catalyst. What is Ziegler-Natta catalyst said? Ziegler-Natta catalyst is titanium chloride, TiCl4, and triethyl aluminum, triethyl or trimethyl aluminum. That means I told you like this way. And what they have given? They have given Al2ClC2H5 6. Same thing, no problem. What I have told you is like this, Al C2H5 3. Because but aluminum, as they are from group 13, their octet not fulfilled, so they used to form dimer, right? So that's why they have given here Al2C2H5 6. This thing, this combination is called Ziegler-Natta catalyst. Okay, so Haber process is done, polyethylene is done, photography is done. In Walker process, what happens? In Walker process, we need PDCl2, not PTCl2, not PT. We need PDCl2. Okay, we need PDCl2. What is Walker process, sir? Walker process is from double bond if you want to make aldehyde. Okay, let me just go to the next page. From double bond, that means I am talking about alkene. From alkene, if you want to make aldehyde, then you have to do Walker process. And in Walker process, what is the catalyst? The catalyst uses PDCl2 catalyst. Okay, PdCl2 catalyst, but here it is given PtCl2. No, that is not the thing. Okay, so what is your incorrect thing? Option number C will be your incorrect thing. That is your answer here. Okay, option number 3 will be the incorrect thing. Okay, now going to the next question. This question is not a good question, I feel, but yeah, we have to do PBS and you have to react this with O3, liberating Y mole of O2. Okay, so you are getting O2, and obviously PBS and ozone is a oxidizing agent, right? Ozone is a oxidizing agent, so it will oxidize PBS to PbSO4. It will oxidize PBS to PbSO4. Okay, so now balance, you see here you need 4 oxygen, so obviously it will be 4O3, and if it is 4O3, and that means 12 oxygen here, 4 oxygen, so you need 4O2 here. Yes, so now if you compare this with whatever is given, that PBS, you need X mole O3 and you will get PbSO4 plus Y mole O2, then your X value is coming as 4 and Y value is coming as 4. So X plus Y value is 4 plus 4, that means 8 will be your answer here. 8 will be your answer here. Okay, so it's a easy question, but I don't like this type of questions. Okay, this is a good question. So spin only magnetic moment of PT NH3 whole 2 Cl CH3NH2. This is in the coordination sphere and Cl is outside. So whenever the question is like this, I need to understand what is the oxidation state of PT, right? What is the oxidation state? What is the oxidation state of PT? That we need to understand. What is the oxidation state of PT? So okay, so for that I will take PT as X. Ammonia is neutral, so 0. Chlorine is -1. Okay, CH3NH2 organic neutral, 0. Chlorine is -1, is equal to, I can say, overall 0. Okay, so X minus 2 equal to 0, X equal to +2. That means that PT is in +2 oxidation state. PT is in +2 oxidation state. But sir, the thing is, I don't know about PT. You don't have to know. You know, do you know about nickel, platinum, palladium? Or sorry, I have done a mistake. Sorry. Nickel, palladium, platinum. Do you know? They are from the same group. So PT2 plus, you don't have to see. You nickel 2 plus also, that nickel 2 plus, do you know or not? Yes, and nickel 2 plus, I know that it is a D8 system. So PD2 plus is also D8 system. PT2 plus is also D8 system. That you have to understand. So PT2 plus is a D8 system. By this way you have to think. Okay, you see all the electronic configuration I cannot remember, right? So we have to do these things. They are from the same group, that you have to understand. Okay, they are from the same group. Okay, so sir, you are talking about PT2 plus and you understand that this is a D8 system. Okay sir, if this is a D8 system, then you write it like this way: 1 2 3 4 5 6 7 8, and we are having 4s, we are having 4p, we are having 4d also here. 1 2 3 4, this is 3d, this is 4s, 4p, 4d. I don't know if it is required or not, but always remember, lower, like not lower, we should write 5d elements forms low spin complex, preferably 5d series. That means PT. Sir, why it is 5d series? Nickel is 3d, palladium is 4d, platinum is 5d. As you are going down this group, low spin complex is forming more and more. Low spin complex is forming more and more. Okay, low spin complex are forming more and more. So what will happen, sir? There will be electron pairing up. Yes, very good. There will be electron pairing up, and these two unpaired electron will get paired because I want to form low spin complex. And sir, if this is the case, I got my answer that n, that is number of unpaired electron, is 0, and mu, that is the magnetic moment, is root over n into n plus 2. That means root over 0 into 0 plus 2 is nothing but 0. Sir, I got my answer. Here the answer will be, the spin only magnetic moment will be a big 0. That will be my answer. Got it or not? By this way you have to do this question. Okay, then coming back to this question, formation of C4 plus is favored by inert gas configuration. Okay, so I hope you know that xenon is 54, right? Xenon is 54, and lanthanide series starts from 57, right? It starts from 57, lanthanide. Then it comes cerium 58. Okay. What is the common oxidation state? What is the common oxidation state of all the lanthanides? What is the common oxidation state of all the lanthanides? Said that is Ln3 plus. Ln3 plus is the common oxidation state of all the lanthanides. Okay. So formation statement 1, you see, formation of cerium 4 plus is favored by inert gas configuration. I think sir it is correct because cerium is 58. If it gives 4 electron out, then it will be cerium 4 plus, and if it gives 4 electron out, then it will have inert gas configuration. Then it will have, I should not say like this way, yeah. So 58 minus 4 electrons, so it will be 54 electron. Sir, now it is having nearest inert gas configuration. Yes, so cerium 4 plus is easily achievable because it is having an inert gas configuration, and that is quite stable. So S1 is correct. Now they are saying cerium 4 plus acts as a strong oxidizing agent and convert to cerium 3 plus. Let's see what about this I can do. They are saying cerium 4 plus is an oxidizing agent. So first of all we have to understand. Hello, yes, I guess everything is correct. Yes. So first of all we have to understand what is oxidizing agent. Sir, oxidizing agent means it will oxidize others. If it oxidizes others, that means it will reduce itself. Sir, if it reduces itself means it is taking electron. It should take electron. It is taking electron. So now you tell me you are having cerium 4 plus. Will it take an electron to go to cerium 3 plus? The answer is obviously it will go. Obviously it will go. Why? Because for all the lanthanides, the stable oxidation state is Ln3 plus. All the lanthanides, if it is lanthanide, Ln3 plus, cerium 3 plus, praseodymium, neodymium, anything, they all are having this plus 3 as their common oxidation state. So sir, definitely this reaction will go. That means sir, cerium 4 plus will take a electron. As it is taking electron, so this is a reduction reaction. So sir, it is reducing itself, it is oxidizing others, and it's an oxidizing agent. All the things, you see, your concept should be very clear. Don't go for any tricks. Okay, trick will not give you marks in the exam. You will get 1 or 2 questions, but your concept should be very clear. So sir, statement 2 is also correct. So both the statement is correct. Both are correct. Are you getting my point or not? Both are correct. Okay sir, then go for next question. which of the following cannot act as a oxidizing agent? You see how I am doing this question. Very easily I can do this question, but for your better understanding, I am doing the question like this. You see, oxidizing agent. That they are asking for oxidizing agent. Sir, oxidizing agent means it will oxidize others. It will oxidize others. If it is oxidizing others, then it will reduce itself. It will reduce itself. And said reducing itself means it will take electron. It will take electron. It will take electron. Okay. Now MnO4 minus. MnO4 minus. Mn here is in which oxidation state? Sir, manganese. Manganese is X plus 4 into oxygen. Each oxygen is -2 equal to -1 total charge. So X equal to +7. So sir, manganese here is in +7 oxidation state. Can it take electron? Sir, definitely it can take electron. It can take actually 5 electron it can take, and it can go to Mn2 plus. Sir, yes, definitely it can take electron. Okay, very good. Now come to BrO3 minus. BrO3 minus. I hope you know Br here is in 5 oxygen state. No sir, I don't know. No problem. Do Brx 3 into oxygen -2 equal to -1, X equal to +5. Sir, Br +5. Sir, can it take electron? I think it can take electron. It can take, I think, 6 electron also it can take to go to Br minus, right? Sir, definitely it can take electron. Okay. SO4 2 minus, sir, do SO4 2 minus. I am not doing the calculation. SO4 here, sulfur is in +6 state. Sir, can it take electron? Definitely it can take electron. It can go to S2 minus. It can take 8 electrons. Sir, definitely it can take electron. But sir, why you are not doing it for N3 minus? Yes. N3 minus. It is already in -3 state. That is its lowest oxidation state. Lowest oxidation state. Nitrogen cannot get any further. Suppose if it takes an electron, it will be N4 minus, or suppose it takes another electron, N5 minus. No, they are not possible. N3 minus is the lowest oxidation state. N3 minus is the lowest oxidation state. So they cannot take electron. Sir, if they cannot take electron, they cannot reduce itself. If they cannot reduce itself, they cannot oxidize others. If they cannot oxidize others, they cannot be a oxidizing agent. They cannot be a oxidizing agent. So option number 2 will be your answer. Option number 2 will be your answer. Got it or not? Got it or not? Tell me. Got it, right? Okay, the quantity that changes with temperature. You see, this is from solution chapter, or we can say some basic concept. We can say molarity. Already we have done number of moles per 1000 ml, or we can say 1 liter solution. So already you see here we are having a volume factor. Here we are having a volume factor. And volume factor, volume depends upon temperature. Volume depends upon temperature. Sir, how it depends upon temperature? We know temperature increases, volume also increases. As there is in the definition, we are having volume factor, so it is temperature dependent. It is temperature dependent. That changes with temperature. That will be my answer. But let's check the others also. Sir, what about molarity? Molality, by the way, is denoted by small m. It is number of moles per 1000 gram solvent. So you see, number of mole also regarding mass, 1000 gram is also regarding mass. No volume factor is there. Temperature is not a factor here. It does not depend upon temperature. Sir, mole fraction. What is mole fraction? What is mole fraction? Okay, let's go to the next slide. Sir, what is mole fraction? Mole fraction, we can say, suppose we can denote it X or chi. Any of the mole fraction is moles of, or we can say number of moles of number of moles of that particle by total number of moles, right? Total number of moles. So we can write it this way, N1 by N1 plus N2. And N1 how to calculate? It will be W1 by M1. N1 is again W1 by M1 plus W2 by M2, like that. You see, all are mass, all are mass, all are mass. No volume factor is there. No volume factor. And if there is no volume factor, that is not dependent on temperature. Got it? Okay. Then what is the question we are doing? Mass percentage. Okay, sir. Mass percentage. What is mass percentage? Mass percentage is in 1000 gram. How many or how much mass is present? Mass is present. So you see, again, this is in mass and mass. There is no volume factor. There is no volume factor. There is no volume factor. If that is no volume factor, then they are all temperature. They are all temperature independent. They are all temperature independent. So sir, what is my answer? You already got your answer. Molarity will be your answer. Got it or not? Got it? Okay. Now come to here. This is a very good question. I just love this type of questions. Yeah. Reduction potential of hydrogen electrode at pH 3. So the equation for hydrogen electrode is H plus electron. From here you will get half H2. This is gaseous state. Okay. So first of all, E naught cell value is what? E naught cell value of hydrogen electrode is 0. Why? Because it is a standard hydrogen electrode. Standard hydrogen electrode, and by convention the E naught cell value is 0. E naught cell value is 0. But said they are asking for reduction potential at pH 3. At pH 3. So for that we have to use Nernst equation. For that we have to use Nernst equation. Okay sir, let me use the Nernst equation, no problem. What is Nernst equation? Nernst equation is E equal to E naught minus 0.059 by N log, we can say, product by reactant. Product by reactant. Sir, if this is the case, here N is the number of electron change, right? Yeah. E naught cell value is 0. We already got it from here. Minus 0.059 by N, number of electron change is 1 electron change, sir. Log, this is product is what? H2. That is I am taking at 1 atm, sir. Why? Because no value is given, so I should take it as 1 atm. No problem. By H plus. Reactant is H plus ion. Okay, sir. I understand this term till this part I got. Okay, so from here I am writing this again in the next page. So E equal to minus 0.059 log 1 by H plus, you got. Always remember that pH is what? pH is equal to minus log of H plus ion concentration, right? Minus log H plus ion. If you write, you can get to this part, you can write it as pH. Okay, so my motive is to go till that part. So minus 0.059, can I write it as log H plus to the power minus 1? Yes sir, that minus 1 I can take outside. I hope you know the log properties, right? Okay, so minus 0.059 into, can I write minus log H plus ion concentration? Said definitely you can write. And said definitely you can write this value as nothing but pH. Why? Minus log H plus is pH. Said pH value is already given 3. So you put the value as 3 and you will get answer 0.177 volt, and that will be your answer. Minus 0.177 volt, that will be your answer. Nothing. We have done some log property I have used, that log a to the power b is equal to b log a. This property I have used here. You see, this minus 1 I have taken outside. This minus 1 I have taken outside. Okay, then pH is equal to minus log H plus. These properties I have used and I got my answer. Got it? So easy, right? Okay, identify the species in which central atom is in dsp2 configuration. Okay, how to do it, sir? The thing is that in octahedral geometry I should write, there are two conditions. One is sp3d2, one is d2sp3. You see here the outer d orbital is used, so it is called outer orbital complex. And here d2sp3, that means the inner d is used, that is called inner orbital complex. Okay, inner orbital complex. Okay, so please remember, if you are having only coordination compound, or we say coordination complex, then only there is a possibility of inner orbital complex. Please listen carefully. I am not saying that coordination complex means inner orbital. No, I am saying coordination complex, if that is a coordination complex, then only there is a possibility of having inner orbital complex. That means in coordination, outer orbitals are also possible, inners are also possible, but if that is not a coordination, always it should be outer. That means I am saying that SF6, it is not a coordination complex, right? SF6, it is not a, just a minute, yes, SF6, it is not coordination complex, not a coordination complex. So here it should always be outer. Are you getting my point? BRF5, not a coordination complex. If it is not a coordination complex, it's always a outer orbital complex. Okay, now sir, go to the next page. PtCl4 2 minus. Sir, it cannot be sp3d2, or it cannot be d2sp3. Sir, why? Because its coordination number is 4. You see 4 ligands are there. If 4 ligands are there, that means it can be having two possibility. One is sp3, another is dsp2. One is tetrahedral, another one is square planar. Are you getting my point? So you don't have to check for this. Okay sir, I understand that I have to check for cobalt NH3 3 plus, and without checking also I can say that will be my answer. Yes, but we have to check cobalt NH3 3 plus. So the first thing first is cobalt is in 3 plus oxidation state. Now cobalt normally is 27. It is argon 4s2 3d7. Cobalt 3 plus is then 4s2 electron gone and 1 electron from 3d7, that will be 3d6. Okay, 1 2 3 4, 4s 4p. This is 3d, this is 4s, this is 4p. 1 2 3 4 5 6. Now in presence of ammonia. Now ammonia is a moderately strong field ligand. We can say moderately strong field ligand. If it is a moderately strong field ligand, then it can pair up. Pairing up will take place. But there is another factor, as it is at D6, so D6 means T2G will be highly stable. All these things I am not going right now in detail. So the thing is, yeah, it will pairing up will take place. So if pairing up will take place, then it should be like this. Yes, 4s and 4p will be like this. Then sir, from here I am getting 2d, from here I am getting s, from here I am getting p3. So totally I am getting d2sp3 hybridization. d2sp3 hybridization. Sir, NH3 will come here, right? Yes, NH3 will come here, 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 d2sp3. That means that it is inner orbital complex, right? Yes, it is inner orbital complex. By this way you have to do this. So sir, the answer of this question is definitely option number 4. Option number 4. Got it? Got it? Yeah. So now this question is quite easy. So we can say that delta H value is given, delta S, delta G value is given, T is given, you have to find log K. Okay. So we know that delta G or delta G naught is equal to, we can say, minus RT, not log, it should be minus 2.303 log K. Oh my god. Minus 2.303 RT log K. Sorry, minus 2.303 RT log K. Okay, and I can find, we know all that delta G naught equal to delta H naught minus T delta S naught. Okay, so if I equate all of these together, then I will get that minus 2.303 RT log K is equal to delta H naught minus T delta S naught, right? Okay sir, then minus 2.303, R value is 8.314, that means I am putting the value in joule. T value I'll put as 300 Kelvin log K equal to delta H value is 77.2, but you see that value is in kilojoule. No, not kilojoule. I already put this value as 8.31 for joule. So it will be in joule unit. Minus temperature will be 300 and S value will be 122. Okay, 122. But sir, why you are not multiplying it by 1000? You see, it is only given in joule. That's why it is as it is. No problem with that. But this value is given in kilojoule. That's why I have to multiply. Okay, so very quickly do the calculation. 77200 minus, it will be 3. So 66, 366 and 00. Okay. So 77200 minus 36000, that means 002 and 36 and 76, 36 and 41. Okay sir, no problem. Then go for the next page. So I got minus 2.303 into 8.314 into 300 log K is equal to what I got? I got minus 41200. Then sir, I can write that log K equal to 41200 by minus 2.303 into 8.314 into 300. Sir, I can write this as like this. Okay, 3 and 412. Okay, I can write this as roughly 400. I can write this as roughly 8. Roughly I can write it as 8. Okay, and this 8 and 400 I can cancel out as 5. So 5 and divided by 50 and 2.3 into 3, that means it is coming around 6, roughly 7 it is coming, 6.9, so 7 means it is roughly coming as 7. Okay, so log K value is coming roughly around 7, minus 7. That will be your answer. So you see how you have to do the approximation. You don't have to calculate the exact value, right? You can take the approximation. and this is the thing you need to learn, how to do the calculation verbally, right? Approximation how to take. Okay, then next question. What is next question? Oxygen only shows -2 oxidation state. That is not a good statement, right? That is not a good statement, sir. Why? Because oxygen use H2O, yes, it is -2, but H2O2 it is in -1. So in peroxo bond, oxygen shows -1 oxidation state, right? -1 oxidation state. So statement 1 that is showing it only shows, no, that is not correct. Okay, on moving top to bottom, stability of +4 decreases whereas +6 increases. No, that is also wrong. Okay, do you see, this is a very good concept. Suppose you are having group 16. Suppose you are having group 16. What you are having? Oxygen, sulfur, selenium, tellurium, polonium. Okay, so oxygen can show -2, okay, -1, 0 also it can show, +1 also it can show. Okay, sulfur and all this, they can extend their valency till +6, but always the last element, please listen carefully, always the last element shows whatever is the highest valency -2. If highest valency or highest, not valency, highest oxidation state is N, last element shows always N-2. This is very important. I don't know if you know this thing or not. This is called inert pair effect. Inert pair effect. It's super important. Whatever is the highest oxidation state of the group, the last element stable oxidation state is N-2, inert pair effect. I am not discussing what is inert pair effect and all these things right now, but you have to know the name at least, inert pair effects. Okay, inert pair effect. Okay, so on moving, what is given here? Let's see. On moving top to bottom, if you move from top to bottom, +4 stability decreases. No, actually from all the elements they are +6. At last only +4 is increases, whereas that of +6 is decreases. No, all the elements they are +6 stable. The last element +4 stable. This is inert pair effect. Here what is given, that is the opposite thing that is given, that is not correct. So both the thing is not correct. Option number 2 will be your answer. Option number 2 will be your answer. Got it? Okay, now how many of them have the noble gas configuration? Okay, this is also quite easy. You have to identify the elements in the periodic table. Identify the elements in the periodic table where they are. Okay, so sir, first thing that I can do is SR2 plus. SR2 plus is where, sir, you are having group 2. You are having what? You are having beryllium, magnesium, calcium, strontium. You got strontium. So group 2 means what? They also +2 oxidation state. They also +2 oxidation state, and in +2 they are having the nearest noble gas configuration. Nearest noble gas configuration, right? Nearest noble gas configuration. So sir, SR2 plus definitely is my answer. Yes, very good. Okay, then sir, CS2 plus, where CS2 plus is there? Okay, you write group 1. What you are having? Group 1, what you are having? You are having lithium, then you are having sodium, then you are having calcium, then rubidium, then cesium, and said they also +1 oxidation state, because that is the nearest noble gas configuration. So CS plus is also my answer. But sir, YB2 plus, where YB is called ytterbium. So I hope you know lanthanide series, right? Lanthanide starts with 57, is goes on and ends with lutetium 71, right? Before lutetium there is YB70. So YB2 plus means what? It is having 68 electron. 68 electron is not inert gas. The nearest is 54 xenon. This is the nearest. So no, this is not my answer. And sir, lanthanum 2 plus, if you do, then 57, 2 plus like 2 electron is gone, you are getting 55. Sir, is it near electron in nearest noble gas? No, nearest is 54. So this is also not possible. So are you getting my point? This is not possible, this is not possible, this one and this one is possible. Got it or not? Got it or not? So the first two is possible, YB is not possible, and LA is also not possible. Just give me a moment. Just give me a moment. Yeah. So this is the case. Got it? Okay. Thank you. Then yeah. So which of the following is having D10 configuration? So if the question is like this, as soon as by seeing this question, I can say, sir, Zn is having D10. Okay. So whoever is having Zn, okay, Zn 30, and it is having argon 4s2 3d10. 4s2 3d10. Definitely said it is having D10 configuration is matching. Said if Zn is having, and in group 12 you are having zinc, cadmium, mercury. Zinc is 30, this is 48, and this is 80, right? If you like, if I taught you already, then I have like how to do the group analysis and all these things I have like taught in detail. Zn, if it is 4s2 3d10, then it will be 5s2 4d10, it will be 6s2 5d10. All are having D10 configuration. Here I need zinc and cadmium. So zinc, cadmium, yes, zinc, cadmium is there. Okay sir, what about group 12? Sorry, what about group 11? What about group 11 sir? Group 11 we are having copper, Ag and Au. Copper is 29, 47, and this is 79. Okay sir, copper, what is the electronic configuration? I am having copper as argon. There is an exception, it is 4s1 3d10. Sir, 4s1 3d10 means it's matching. Okay, then sir, for Ag I'll have not argon, we'll have argon xenon 5s1 4d10. Okay, then probably we'll have neon, helium, neon, argon, krypton. Sorry, it is not xenon, it should be krypton. I have done a mistake. It should be krypton and then it is xenon. 6s1, then there will be 5f14 and then it will be 4f14, and then we will have this 5d10. Okay, no problem with that sir, I don't need these things, I need this one and this one. So copper and Ag is also having D10 configuration. Sir, all are having D10 configuration in option number 4. Yes, option number 4 will be your answer. Option number 4 will be your answer. By this way you have to do these questions. Okay, very easy, we can do this question by this way. Okay, then this is a good question. This is a good question. So how to do this question? You see, carbylamine test. Carbylamine test is for test of we can say primary amine. It is a test to detect primary amine. Any primary amine. It can be aliphatic, it can be aromatic, anything. You take RNH2, that is your primary, or we can say 1 degree amine. You react this with chloroform in presence of KOH and you will get RNC. I am not going for mechanism right now. I will teach you afterwards. Okay, like in my class, I have already taught you, and whoever wants to do this, like wants to know it, you text me, I will do. Now this is, you are getting alkyl isocyanide, alkyl isocyanide, alkyl isocyanide, and this is having a very bad smell. This is having a very bad smell. By the smell we can identify what if this is primary amine, and that is called carbylamine test. Then sir, what about Lucas test? What about Lucas test? Yes, so now we have to go for Lucas test. Lucas test, sir, what is Lucas test? It is to detect or to identify 1 degree, 2 degree and 3 degree alcohol. 1 degree, 2 degree and 3 degree alcohol. Sir, 1 degree alcohol means RCH2OH. 2 degree alcohol means RCHOH R dash, and 3 degree alcohol means RCR dash R double dash OH. Lucas reagent is anhydrous ZnCl2 plus concentrated HCl, and the reaction will go by SN1 mechanism. SN1 mechanism. Okay, I am just giving you the gist of this. Anhydrous ZnCl2 plus concentrated HCl, the reaction will go by SN1 mechanism. Said carbocation formation stability, SN1 means it is carbocation, and stability of carbocation order is 3 degree greater than 2 degree greater than 1 degree, that we know, sir. So from here what you will get, this is, from here you will get 3 degree, 2 degree, 1 degree, this is 3 degree. So from here you will get the most stable carbocation, you will get immediate reaction, immediate turbidity, you will get immediate turbidity, you will get. Okay, from here you will get RCHR dash Cl. From here you will generate 2 degree carbocation. Okay, this reaction will also go, but this will go, the reaction like turbidity you will get after 5 minutes. Turbidity after 5 minutes. Okay, and here you will get RCH2Cl, no turbidity, or you will get turbidity after so long. So by seeing the visible change, we can identify 1 degree, 2 degree or 3 degree alcohol. Okay, 1 degree, 2 degree or 3 degree alcohol, and this is called Lucas test. This is called Lucas test. Okay, then what is given here? Tollens test. Okay sir, then go for Tollens test. Tollens test. Tollens test. Tollens test is to identify between or differentiate between anything. You can write identify between aldehyde and ketone. Aldehyde and ketone. Sir, what happens? Suppose you are having aldehyde like this, RC double bond OH, and suppose you are having ketone like this, RC double bond R dash, right? This is aldehyde and this is ketone. So what happens if you are giving tollens? That tollens means AgNH3 whole 2 plus OH minus. Okay, AgNH3 whole 2 plus OH minus. Similarly here also you give AgNH3 whole 2 plus OH minus. Ammoniacal silver nitrate, this is called tollens. You will get here silver mirror. You will get silver mirror here. Here no reaction. So by this you can identify it's your aldehyde or it's your ketone. Aldehyde reacts positively in tollens, ketone does not react. Okay, so by this way you can do the reaction. But sir, here they are asking for phenolic group test. Sir, this one is for primary amine. Tolerance is for aldehyde ketone. Lucas is for alcohol. Then sir, phenolic OH, this definitely be the option number 4 will be the answer. Phthalate ditrest, yes, but we have to understand what is phthalate ditrest. Okay, we have to understand what is phthalate ditrest. So for that we have to go to the next page. Yes, phthalate ditrest. So this is so easy. I hope you know phenolphthalein, right? How to make phenolphthalein? Do you know? This molecule, do you know? This the name of this is phthalic anhydride. The name of this molecule is phthalic anhydride. Phthalic anhydride. This phthalic anhydride, if you react with phenolic OH group, two molecule is needed. Okay, two you will get this molecule. I am not doing the mechanism right now because then it will be a very long lecture. Nothing, just from the para position of the phenol group you have to attack and you will get this molecule. There is nothing more like important here. Okay, this you will get. Okay, if you gave NaOH here, what will happen? If you give NaOH here, what will happen? NaOH will take this OH and this H because they are acidic, right? They are acidic, so you will get this kind of thing. You will get this kind of thing. Phenoxide ion kind of thing, right? Phenoxide ion kind of thing. But one of them will do resonance. One of them will do resonance like this. It will do resonance like this, and it will break the bond and you will get this thing like this. Okay, and probably on the another hand you will get this, and another hand you are getting O minus and double bond O. I think I have done it correctly. Let me just check. This will go here, this will go, yes, it will be like this. Okay, this will be like this. Now this is giving a pink color. This is nothing, this is just phenolphthalein I have made. I have just made phenolphthalein here. I have just made phenolphthalein here. Okay, and it will give a pink color, and this is called phthalate ditrest. This is called phthalate ditrest, and that is for this phenolic OH group. This is to identify this phenolic OH group. Got it? Phenolic OH group. So here option number 4 will be your answer. Okay, then go to this question. This question is a very good question. I like this question. So O, this molecule is given HI. So what is this reactions called? These reactions are called ether cleavage. These are called ether cleavage. Okay, ether cleavage. What we'll do now? Oxygen lone pair. You will take this hydrogen and this I will leave. Then you will get this thing. You will get this thing. Now I want to take this to the next slide. I want to take this to the next slide. Yes. So you got this thing. Now in the medium you are having I minus. First of all, this molecule will decide it wants to go to SN1 or it wants to go to SN2. The molecule will decide if it wants to go by SN1 or if it wants to go to by SN2. How? When it will go by SN1, it will go by SN1 only if very stable carbocation forms. Very stable carbocation forms. Very stable carbocation forms means it may be a 3-degree carbocation or a resonance stabilized carbocation. Or a resonance stabilized carbocation. If this criteria fulfills, then only it will go by SN1. Otherwise, it will go by SN2. Otherwise, it will go by SN2. Okay. Okay. Now you say, if you break this bond, oh my god, I am getting a stable carbocation. I am getting a stable carbocation. That means that you are talking about, okay, so here we are having a hydrogen, right? Yes. Sorry for that. Yes, sir. Now if I break this bond, I will get a stable carbocation, CH3C, CH3, CH3 plus 3 degree carbocation, I minus will attack here. I will get CH3C, CH3, CH3I. So sir, I got my answer. I got my answer. This is my product. I think that it is not phenol, cyclohexanol. Yes, and said this is my product, and the reaction goes preferably by SN1 to give me the product like this and this. Got it? It goes by SN1. And why it goes by SN1? Because it can form a stable 3 degree carbocation. A stable 3 degree carbocation. Then which is your answer? I guess option number 2 is matching very beautifully, and that will be your answer, right? Okay. Then this reaction, okay, we have to do. The first thing that is coming to my mind is that phenol with chloroform NaOH, it is Riemann-Tiemann reaction. This is Riemann-Tiemann reaction. And in Riemann-Tiemann reaction, we get salicyl aldehyde. That means from here I can get 2. Okay, then said this thing, then last one is Kolbe-Smith reaction. Kolbe-Smith reaction, and from there sir I got salicylic acid. Okay, now I will do all the reactions I will do, and then NaOH CH3 I will get anisole, and here it's a oxidation I will get. Okay, understand? Now go to the next page. So from phenol, whatever I have told you, from phenol there is 2 important reactions from phenol that you have to know at any cost. That you have to know at any cost from phenol. Phenol is reacted with CO2/NaOH, like the last one, CO2/NaOH, and then after that it is doing hydrolysis. This is called Kolbe-Smith reaction. I am not doing the mechanism here, then it will be a very large, like very long video. Kolbe-Smith reaction, and you will get OH, and at the ortho position you will get COOH. The name of this molecule is salicylic acid. Salicylic acid. And from phenol, if you react this with chloroform and KOH or NaOH, anything with last step hydrolysis, then you will get OH and you will get C double bond OH. The name of this molecule is salicyl aldehyde. This reaction, I told you, this reaction name is Riemann-Tiemann reaction. Riemann-Tiemann reaction, and the main factor of this is it goes via CCl2 carbene intermediate. CCl2 carbene intermediate, right? It goes via CCl2 carbene intermediate. Okay, then 2 more reactions are there. One is phenol is reacted with NaOH. So from NaOH, what you will get? You will get O minus. O minus will take this hydrogen and this will leave. So you will get O minus. You will get phenoxide ion. Yes or no? Tell me. O minus and obviously Na plus. You will get phenoxide ion. If phenoxide ion you got, and here you react this with CH3I, obviously a SN2 reaction will take place. This is called Williamson ether synthesis. I hope you know. If you don't, then you please revert back to me. I will discuss these things with you. Williamson ether synthesis, you will get benzene ring OCH3, and the name of this is anisole. The name of this is anisole. Okay, there is another reaction we can do here only. Phenol, if you react this, preferably it is a very special reagent, Na2Cr2O7. It's an oxidizing agent. Okay, it's a oxidizing agent. If you react this phenol, you will get this molecule, parahydrobenzoquinone. It's a oxidized product. It's a oxidized product. So these are the reactions that you have to know, and you already got your answer that from NaOH you will get anisole, and from here Na2Cr2O7 you will get this. So I am writing here P22 and then Q21 R24 and S23. That will be your matching. Okay, then going to the next question. How many questions are left? Oh my god, so many questions are left. 1 2 3 4 5 6 7 8 9. Oh my god. Okay, so here we can do this like this. When egg is boiled, which of the primary protein remains intact? Okay, so protein, there are four kind of structure. One is primary structure. In primary structure there is only peptide bond. From primary structure you will get secondary structure. In secondary structure, what happens? You are having two things. One is called alpha helix, one is called beta sheet, and it is happening due to hydrogen bonding, due to hydrogen and disulfide bonding. Okay, hydrogen and disulfide bonding. Then from secondary you are getting tertiary structure. It's a coiled structure. And from tertiary you are getting quaternary structure. And quaternary structure, it is a perfectly coiled, native structure, native protein structure. Okay, then what happens there? If you heat it, quaternary structure breaks, tertiary structure breaks, secondary structure breaks, but primary structure remains intact. All of these you can break, but primary structure you cannot break. So here your answer will be option number 2. Option number 2 will be your answer. Got it? Okay, go to the next thing. Which of the following compound will not give SN1 reaction? Said SN1 reactivity is, we can say, it's related to stability of carbocation. Okay, but we don't have to go this far. What we can do is that we can take the last molecule, CH3 CH double bond CHCl. The chlorine is having lone pair and said that can participate in resonance, and if it participate you are getting CH3 CH bond CH double bond Cl. This is plus and this is minus. Sir, what is the problem with the resonance? The problem with the resonance is that in SN1 reaction, it's a substitution reaction, right? It's a substitution reaction, and in substitution reaction, what you want? You want to substitute the chlorine. You want to break this bond. And you want to substitute it by something, any nucleophile, right? Any nucleophile will come and you want to substitute the chlorine. but the thing is the leaving group, your leaving group chlorine is actually participating in resonance, and after resonance it is having a double bond character. You see, it is having a double bond character. So I can say that carbon and leaving group is having a partial double bond character, and as it is having double bond character, then the bond becomes strengthy. The bond strength is more. You cannot just break this bond. Are you getting my point or not? You cannot break this bond. Said if I cannot break this bond, that will not participate in SN1 reaction. Sir, what about the other ones? Yes, I'm writing the first one. I guess first one is looking like this. CH2 double bond. Okay. CH2 double bond, CH bond, CH2Cl. You see from here, this chlorine, if you want to participate in resonance, you have to break the sigma bond. But that sigma bond breaking is not a resonance. Yes, in resonance we cannot break the sigma bond. Moreover, if you remove this, then you are getting CH2 double bond CH bond CH2 plus. This carbocation is a resonance stabilized carbocation. Resonance stabilized carbocation, right? This is a resonance stabilized carbocation. Okay, sir, if this is the case, then PHCH2Cl, go for the next one. PHCH2Cl. Yes, if you remove this, you are getting benzene ring. With CH2 plus, benzene ring with CH2 plus, and said that is also a resonance stabilized carbocation. Okay, then from the third one, what is the third one that is given? Let me check. Okay, third one is given is CH3 CH3Cl. Sir, if I leave this, I will get CH3 CH3 plus. So that is also, we can say, quite stable. 2-degree carbocation having 6 alpha hydrogen, right? Hyperconjugation index, so it is quite stable. So they all can go by SN2, SN1. But the thing is that here the last one you cannot, because of the partial double bond character, that you cannot. So option number D will be your answer. It cannot go by SN1 reaction. Option number D will be your answer. Got it? Okay. The second homologue of monocarboxylic acid. Okay. So this is probably the easiest question. Monocarboxylic acid. So for one carbon, it will be HC double bond OH. Second carbon is what? H. Then you need a CH2. Then you need C double bond OH. And this H and CH2 you can combine. You can write CH3 C double bond OH. First one, it is methanoic acid. There is a common name for this also, that is called formic acid. And this one is called ethanoic acid. And there is a common name for this also, that is called acetic acid. So this is your answer, is option number 2. Option number 2 will be your answer. Got it? Okay. Then I love this question. This question I will do in detail. B2H6 is given. B2H6, H2O2 and OH minus. Said this reagent, do I know this reagent? Of course you know this reagent. This reagent is for hydroboration oxidation. Hydroboration and oxidation. And this is what I told you. I'm not doing the correct mechanism right now, okay? I'm just doing like, you can do by this way also. This is anti-Markovnikov water addition. Anti-Markovnikov water addition. That means you have to add water, and you have to add water like this way. Anti-Markovnikov water addition. Got it? Okay, sir, got it. Then it is given HBr. Sir, HBr, then oxygen lone pair will take this hydrogen and bromine will leave. Sir, we have to go to the next page. Yes. So, benzene ring with CH2, OH2 plus you are getting, and this OH2 plus is a good leaving group. We can say this is a good leaving group. Sir, if this is leaving, then I am getting benzene ring with CH2 plus. But sir, this is not a stabilized carbocation. This is not resonance stabilized. Yes, I understand that this is not resonance stabilized. But sir, if this is carbocation, then sir, you can do rearrangement. Yes, this hydrogen I will shift here. Like I have taken 3-4 hours class only for this carbocation rearrangement, right? You have to apply this carbocation rearrangement. So hydrogen 1,2 shift. Sir, why you are doing this shifting? Because if I do the shifting, I will get a stable carbocation. You see, now I am having this positive charge, and that can do resonance with the benzene ring. That is resonance stabilized. That is resonance stabilized. Okay. Now this is a 2-degree resonance stabilized, and here Br minus will attack, and sir, I will get CHBr CH3. Till this part we have done. Okay, sir, what is given next? It is given Mg dry ether. Okay, sir, no problem. We can do this. We just have to go for the next slide. Yes. So till now I got benzene ring with CH3 Br. And if I react this with Mg dry ether, I will get benzene ring with CH3 MgBr, right? MgBr. Sir, this is Grignard reagent, right? Yes, this is Grignard reagent. Okay, sir, Grignard reagent. And what is the last step, sir? Last step, it is given formaldehyde. No problem, sir. This is plus delta, this is minus delta. Minus will attack here. Sorry. Minus will attack here, and this will leave. Okay. Now I have to change the color. Yes. So benzene CH3, then benzene CH3. This negative, like from this carbon, I am bonding this carbon. Okay, CH2O minus MgBr plus, and obviously last step you have to do hydrolysis. And if you do, you will get beautiful benzene with CH3 CH2OH, right? You'll get this molecule, and this molecule is very beautifully, it is matching with option number A. This type of question after doing also will get so much satisfaction, right? Like, yes, we got this correctly. So you see, first step is hydroboration oxidation. Second step is carbocation formation. Then carbocation rearrangement. To get the most stable carbocation. Then bromine attack, you are getting bromide. Then it's Grignard reagent. Grignard with formaldehyde, it will automatically give you 1 degree alcohol always, and that will be your answer. Got it? Got it? Okay. Now what is this question? When 9.3 gram of aniline, okay, aniline means aniline is looking like this, right? Aniline reacts with acetic anhydride. Acetic anhydride is like this: CH3, C double bond O, O, C double bond O, CH3. So you are getting acetanilide. Obviously minus H plus you have to do, you will get acetanilide, NH, C double bond O, CH3. Okay, 9.3 gram. Okay, aniline means it is C6H5 means this phenyl structure and then NH2, right? So we can say C6H7N. Carbon is 12. So 12 into 6 plus hydrogen is 1. 7 into 1 plus 7 into 1 plus 14. So 72, 7, 14 means 93. Okay. Its molar mass is 93. Okay. This is phenyl ring is C6H5, then NH, CO, CH3. If I combine, then how many carbon? 6, C8, H5, 8, 5, 6, 9, C9 and nitrogen and O. Okay. Carbon is 12 into 8 plus hydrogen is 9 into 1 plus nitrogen is 14, oxygen is 16, 30, 126, 135. Okay, 135 gram. Okay, so very easy. From 1 mole you are getting 1 mole. Okay, so from 9.3. Okay, sir, I can do this like this way. That 93 gram aniline, from here you are getting 135 gram acetanilide. So from 1 gram aniline you will get 135 by 93 gram acetanilide, and from 9.3 gram aniline you will get 135 by 93 into 9.3, it will be 10, that will be 13.5 gram acetanilide. That will be your answer. Let's check. Formed is x gram. Report your answer as 10x. Okay, they have done something new. So this is what you will get, but you have to report your answer as 10x. This is the value of x. Okay, so 10x means 10 into 113.5, that will be 135, and that will be your answer. That will be your answer. Okay, so by this way you have to do it. Okay, next question. The stability order of the following resonating structure. Okay, you are having CH2 double bond CH bond C double bond OH like this. So this is a neutral structure. This is a neutral structure. Always neutral structure is more stable than charge separated structure. Okay, charge separated structure. Always neutral structure is more stable than charge separated structure. Okay, so one will be more stable, but if you do resonance here, you have to do the resonance like this: CH2 bond CH bond CO minus H, and it will be plus. Or you can do the resonance like the other way also, but that is not a good way, because you see oxygen is electronegative, right? Oxygen is electronegative atom. If oxygen is electronegative atom, then oxygen with a negative charge, it should accommodate negative charge better, right? It should accommodate negative charge better. So oxygen as a negative charge greater than oxygen with a positive charge, the stability order. As oxygen is an electronegative atom, so oxygen will accommodate the negative charge better than oxygen can accommodate the positive charge. Are you getting my point? So you see here what is happening. Oxygen with a negative charge, that is stable. Oxygen with a positive charge, that is unstable. But who is the most stable? This is the most stable because it is a neutral structure. So the thing here is 1 is the most stable, followed by 2, followed by 3. Which option is matching? 1 greater than 2 greater than 3. That means option number 2 is matching very beautifully. Option number 2 is matching very beautifully, and that will be your answer. Okay. This question is super easy. You see steam volatile and water immiscible. Always steam volatile means you have to go for steam distillation. There is nothing you can do with this. It's so easy. Option A. Sorry, not option A, option 1. Option 1 will be your answer. Okay, steam volatile. So you have to do steam distillation. Okay, then here you see this question is also good. How many of the following compound contains chiral center? So chiral center, sir, what is chiral center? Chiral center, we are discussing chiral center. We are discussing chiral center when carbon. We are discussing chiral center because carbon with X, Y, Z and W. In 4 hands it is having X, Y, Z and W. When X not equal to Y, not equal to Z, not equal to W, then this is called chiral center. That means all the groups attached with the carbon atom should be different. All the atoms all the groups attached to the carbon atom should be different. Okay, then we can say that is a chiral center. Okay, now we will do one by one. So for the first molecule, if I check, I can say that this carbon I am talking about, you see one hand methyl, one hand hydrogen, one hand this group and one hand this carbonyl. So this carbon, all the groups are different. So this is a chiral center. Are you getting my point? So you can do this type of thing. Let me just, yes. So we can do this type of thing here also, that double bond O like this. But you see all this carbon is having 2 hydrogen. All this carbon is having 2 hydrogen. All this carbon is having 2 hydrogen. So no chiral center. No chiral center. Are you getting my point? Then this molecule we have to do CH3 CH2 CHOH C double bond OOH. Okay, sir, this is having chiral center. This center you see, this is a ethyl group, this is a OH group, this is a H group, this is a COOH group. All are different. All are different. All are different. So, sir, it is also a chiral center. Okay, it is also a chiral center. Okay, then sir, fourth one you do. Fourth one, if you do the fourth one, it will be COOH, it will be NO2. Sir, this is different for this carbon. This methyl group is different, this total group is different, and this hydrogen is different. Sir, this center is also a chiral center. This center is also a chiral center. Okay, then 5, if you do, like, it will be like this. I here actually 2 chiral centers are there. You check for this methyl different, I different, hydrogen different, and this total group this different. So this is also a chiral center. This is also a chiral center. Okay, what is the next one given? Okay, the next one is actually the funny one. CH3 CH2 CH C2H5 and OH. Okay, let me write it in a very good manner. So it is given CH3 CH2 CH C2H5OH. You see in this carbon, I'll talk about this carbon. This group is OH, C2H5. This is OH. This is H, different, but this is C2H5 and this is, these two groups are same. You see CH3, CH2 and C2H5. That means same thing, right? They are same group. So this is not a chiral center. Okay. So what are the chiral centers, sir? What are the chiral centers you got? This I got, this I got, this I got, this I got, and no more. So total four structure. This is not and this is not. Are you getting my point or not? This is not and this is not. Got it? Okay, then last, yeah, the bond line representation of the following molecule. What is the molecule given, sir? The molecule given is CHOH CN whole 2. So if I write it normally, it will be the carbon, I should write carbon with a OH group, with a hydrogen, with a CN here, with a CN here. In bond line formula, what you have, you don't have to show carbon and hydrogen. You don't have to show carbon and hydrogen. You don't have to show. Okay, carbon and hydrogen you don't have to show. Only any heteroatom. Heteroatom means that, heteroatom means I can say oxygen, fluorine, chlorine, nitrogen, sulfur. These you have to show, and its associated carbon also you can show. Okay, only heteroatom you have to show. Okay, sir. So that means that you are saying this carbon I don't have to show. No, this carbon you don't have to show. You just write like this. So OH, CN, CN. Said this hydrogen, no. Carbon and hydrogen you don't have to show. Carbon and hydrogen you don't have to show. I will automatically understand that there it is a carbon, and with that a hydrogen is there to satisfy the tetravalency. Yes, got it? So by this way it is your bond line structure. This is your bond line representation. Okay, this is your bond line representation. Okay, that means that in my case option number 3 is matching very beautifully, and that will be your answer. That will be your answer. Got it? I hope all are done, right? Let me just check. Yes, T have done. Structure done. All this structure done. This calculation, molarity calculation done. This catalyst and all these things are done. PBX plus Y. Spin only magnetic moment is done. This is from lanthanide DNA block is done. This is also from like the basic concept. Then molarity is done. Electrochemistry, very good question from here. Then it is again from chemical bonding and from coordination complex mixed. Then this is from thermodynamics, it's a good question. This is inert pair effect, that is good. Then this is from noble gas configuration, all this not so good. Okay, D10 configuration, yes, this is good. This is actually a very good question. All these things I have discussed, how to determine what is the organic product and all these things, right? Then it is ether cleavage, very good question, SN1 or SN2. This is entirely from phenol. All the 4 important reaction they have given a question. And this is from biomolecules, SN1, SN2 reactivity question. This is actually a very easy question, monocarboxylic acid second homolog. This is a very good question, all the organic reaction punched together. This is from actually what do I say, numerical basic concept thing, right? This is from resonance, GOC part. This is from purification, and this is Kyleson. This is also a very easy question, and this is from bond line representation, GOC. Yes, so that's it. Thank you guys, thank you, like whoever is till this part. Like all the question I have discussed in very detailed manner. I didn't waste the time and I didn't elaborate the things also. Like I tried to make you understand that why I'm giving this answer, right? Only the, you see, iska answer ye hoga, uska answer ye hoga. Yeah, that is not a very good thing, right? So I tried to make you understand the thing, and if you do understand this thing, you can give me your feedback. or if you have anything to say, you can revert back to me. Okay, thank you so much. Bye.